missing on Monday. I had an urgent meeting, so GAME replaced actually it's supposed to be the exam, but anyway, exam we cannot do. So we moved to the next week Monday. So I think supposed to be probably the last visit to anything related to the immigration for me. But anyways, hopefully it will be finalized. Okay, so then we will have the midterm exam on Monday. Please, I create the test quiz on Canvas that need to install the lockdown browser. So during the exam, so you need to use the lockdown browser, and otherwise you cannot start the exam. So please go to the Canvas. And if you go to the class, so 503, and if you go to the quiz, so there's the test. This requires lockdown browser. So if you do not install the lockdown browser, it will direct to the lockdown browser the installation. I do not have the link to install the lockdown browser directly, so please test it before you come to the class. If you try to install the beginning of the exam, it will take 10 to 20 minutes sometime. So please install the lockdown browser before you come. Then we will start on time, 9:30. It will take 70 minutes. So hopefully we can finish the exam on time. Regarding to the exam, around 40% is the open-ended question, and the other 60% will be the multiple choices from chapter 1 to 6. Any question regarding to the exam? Okay, so there's no makeup exam due to the technical issue on your laptop. Please, another thing is I think this room might be okay because we have the power outlet for each desk. So please bring your adapter to keep your battery power. So otherwise it will be okay. And also bring your one more thing is you cannot leave earlier. So it's just a 70-minute exam. So once the time is even though you complete the exam before the due, but you need to stay until the all students complete the exam. Okay, so then we are going to finalize chapter 6 today, then discuss about the deadlock, the management for the last part of the process management. Last week, we had actually I don't know how many of you attended the colloquium series. Every semester we invite 5 to 6 speakers to the engineering colloquium, which is required for the graduate student for graduation. But most of the graduate students take that course at the first semester. Probably you did the previous semester. This semester also we invite 5 to 6 speakers to UB. Then the last speaker was Dr. Kim from the University of Southern California, USC, which is one of the top schools in the computer science and engineering area. He said that recently the USC changed their curriculum and where they actually pull out the operating system as a core course. So which means operating system is no more core course in their curriculum, only the undergraduate it's the elective course. So I do not fully agree their decision, but I understand something situation nowadays. Do you think why they drop the operating system from the core course? So what is the usual core courses? Is it important and also fundamental or the basic of other subject? in case of the computer science, so it really should be like we have 5 core courses in computer science. The database and operating system that I'm teaching currently, and OOP, and algorithm, and the network, the DCC. So these are the 5 core courses. Mostly they are the basic subject of the other computer science subject. So it's the same thing for any other major. So recently the USC changed their curriculum by removing the operating system. The reason why they changed the curriculum is our computing environment and IT, the environment and infrastructure are quickly changing. So for example, operating system nowadays, so most of the computing resources move to the cloud computing environment, which means instead of the understanding the computer architecture and the operating system, such as more like the hardware part, but nowadays we are focusing on how to use the data, how to process the data. Think about, for example, IBM. So IBM, the 20 years ago, it's around 1990 something, it's probably 20 years ago, the IBM announced IBM is the kind of company for on-demand. So what is the on-demand? They are not IT manufacturer company. Instead, they are IT service company. So they try to make the revenue from the service, like providing the implementation of the IT infrastructure or the developing the software and something like that. So that's the on-demand. So if the customer wants to do something, so then they bill based on their service. Then recently, like the last 5 to 6, 7 years, IBM actually sell all hardware product, including Lenovo, the laptop, and also IBM PowerPC, and their design of the chip, processor, everything they sell to other companies. Then IBM will be what? Data analytics company. So they announce. So which means the computing environment is being quickly changed, which means is it their business? So it's not related to your future. Definitely it's related. So after graduation, some of students want to get a job in United States or get back to your hometown or something. Probably the most of students will be around the IT or computer related job. Okay, some of them will be teacher or instructor or something like that. So if you do not get used to such a changing computing environment, it's very hard to survive over there. So the more like the most of job in future will be related to such a data-driven job. So not only just the coding, the programmer. So you should be able to understand the data that you are handling, and you don't have to implement or design the developing or the new data mining algorithm. However, instead, at least you are able to. So when you think about your future, even after graduation, what you're gonna do? So you need to think about such a changing environment. So that doesn't mean the operating system is not important. It doesn't make sense. It's not possible. Even cloud service, cloud computing has the computing resource as well as the operating system. But the main focus may be different from the previous, like they are interested in the virtual machine and how to build based on the customer research, how to monitor and how to balance and how to scale up what the distributed computing or cloud, the infrastructure, cloud design or architecture. So you can move on. If you are interested in such an operating system or computer architecture, you can think about where you are going to study and research. So even though some of the university drop the operating system from the core courses, that doesn't mean we don't need. So there may be the chance for your also future. They need someone who knows the operating system, or some of the, as you have seen before, the algorithm will be used for the even application. Okay? Do not waste your time in the classroom and during your school life. It's just 1 or 2 years. It's quickly gone. But what you need to know, something you need to know is quickly change. It's very hard to even catch up. So even the next the 5 to 10 years, decade, will be kind of a transition of the new era. Okay? So last 50 years, if you know that something skill, you can survive. Like I can drive a car. So there are a lot of drivers now. So it's okay. So to support support your family by driving a car, but the future, it will be changing. You should be able to understand, you should be able to handle and manage such a data. It's a data-driven society. So next decade, kind of the transition. So nobody knows what is the right answer. So it can be something difficulty, but I think there's also the opportunity. Okay, do not waste of your time. So, but even such a fundamental the subject, operating system, database, or algorithm will be also, I believe, the important part to find the new opportunity. Okay. Okay. So I have waited for students who are late. Okay, we can continue. Let me start with the example of the multi-level feedback queue. So we talk about the scheduling algorithm. There are two types of the scheduling algorithm. One is preemptive, another one is the non-preemptive. Before we start, so on Monday during the exam, if I catch any suspicious thing, okay, automatically kick out, then it will be 0 mark. Okay, don't even think about that. There's no appeal to me. Only the academic honesty, the committee, you can appeal in case you are kicked out. Okay, it's not just warning. Okay, it's my strong policy. So in case I catch any cheating or any types of the suspicious thing, so it will be automatically kick out. Your score will be 0 mark. Then if you do not satisfy my decision, you can appeal to the committee at the UB. So simple way is you can solve the problem by yourself. That's it. Okay, so that's there's no second chance, there's no excuse, just the simple rule, solve the problem by yourself. That's it, okay? Then, we talk about the scheduling. Any question regarding to the midterm exam? You can bring the scratch paper, but probably you don't need a lot, so you can use, and also calculator. If that is not connected, there is no memory function you can use. Also, lockdown browser will provide a simple calculator, so you can use it. But if you cannot use the cell phone should be turned off. If your cell phone is turned on, it will be considered as a cheating. Okay, so cell phone is not allowed. So in case you need the calculator, it's a simple calculator without memory function, without connection. Okay. So any other question regarding to the midterm? Okay, then we will continue the scheduling algorithm. So for the scheduling algorithm, so we talk about the preemptive, non-preemptive. Preemptive usually from time to time, so we will talk about something preemptive algorithm in computer system. When we talk about the preemptive something algorithm, preemptive means it can be resumable. You can stop and start it again. On the other hand, the non-preemptive is once start, it is done. Okay, there's no second chance to start. That is the non-preemptive. So we talk about the first come, first serve. By the way, any algorithm that we are talking about scheduling, we can consider regard all these algorithms as the priority. The problem is what priority we are going to use. If we consider the priority kind of arrival time, that is the first come, first serve. Okay? If we consider remaining job, CPU burst time, remaining CPU burst time, it's the shortest remaining job first or something like that. So anything we can consider regard the scheduling algorithm as the priority based. So first one is first come first serve. It's a simple, it's a non-preemptive case, but first come first serve causes the convoy effect, which means the short running job, short the CPU burst time, the job process will be hidden by long running job. So we may have the longer waiting time and longer response time than expected. So to address that problem, so we can consider the remaining the shortest job first. Okay, so we consider just the amount of CPU time. So non-preemptive case of the shortest job first is we can just consider what is the CPU burst time. Then we can think about the remaining job. In other words, the preemptive case of the shortest job first. So that will provide the faster response time and the better the waiting time. And also we have learned about the round robin. Round robin, we chop the CPU time, then assign the process certain amount of time, which is called the quantum. So if we set the longer quantum size, that means it's a first come first serve. Otherwise, it will provide a faster response time. Problem? It may cause a lot of context switch, so it will be overhead. So the optimal size of the quantum is important. And also, why don't we directly assign the priority number to the process? Then we can just consider priority is a priority based. Any priority based algorithm has the problem of what? It's a starvation. So lower priority cannot get any chances. So in this case, the CPU time. So to address that problem, we can consider aging. Aging means after a certain period of time, so we can promote the priority. Then eventually the process will get the chance. So then that is the single level. So we talk about the multi-level, the CPU scheduling, like we consider the system process is a higher priority, and the lower priority process like the batch job. Then so we can classify the process by the type of or the importance. Then assign the specific level, the queue. The problem, it will be we need also the scheduling along the queue, the level. Okay. And another things that we discussed last time is multi-level feedback queue. In the multi-level feedback queue, so one of the problem of the multi-level the scheduling is it's very hard to decide which one is the system process, which one is the online process, which one is a batch process. So it's very hard to determine such a type of process. Instead, we are going to put all the new process for the first level with the less time quantum, which means it provides a fast response time. It will get the CPU resource anyway. No matter what types of the process it is, it will get the computer resource. In this case, the 8. Then, if that is done, it will be terminated. Otherwise, move to the next level. Next level is longer quantum size. Quantum size is 16. So if that is done, it will be terminated. Otherwise, it will move to the last one. Last one is the first come first serve. But if you implement this one, you don't have to implement it separately. It's a quantum size like the 1,000 or 10,000. It's enough, long enough, big enough. It will be the eventually first come first serve. Then finally it's terminated. So let me demonstrate this one with the slide. This is our process state. Like the process 0 arrival time is 2, CPU burst time is 10, so on. So Q0 is time quantum size 8, 16, and this is the first come first serve. So let me quickly go over, then you can see how it works. For example, the P0 is alive, that requires the 10 CPU time slot, but the Q0 can take the only 8. So eventually, also the time 8. So it's alive at this moment, the process 1. The run, the how long? The process 0. This is a time 8 and alive 2, so still the full remainder. Okay, it demonstrates the current status. Okay, so then what about the P0? P0 the need 10, but the Q0 at the Q0 it will get the only 8 time slot. Okay, so it has a 2 remainder, so that means it moved to the next. Then if there exists, so in this example, the rule 1 is a priority-based queue scheduling, which means if there is any process in the Q0, it will take the CPU resource, then the next and next one. So which means, so since there are processes in the Q0, it will get the CPU resource. Among this, so this is the round robin. So by 8, so you can take the CPU take the which process? This moment. So yellow one is the current, is a running process in this diagram. Okay. So then the P1 is done because the P1 need only the 7 CPU burst time, but so within 1 round it will be terminated. So this is terminated. So we can go on. So why don't you? It's already uploaded the canvas. You can check the one by one. So if we go the next. So like this one, so we can implement the multi-level feedback queue. So then finally you can analyze with what? We learned about the criteria to evaluate the CPU scheduling algorithm. What? Waiting time and response time. So there are more, the throughput and the turnaround time, but we mostly use the waiting time and response time. Using that, you can actually calculate which one is better. So what is the average time of the waiting time and so on. So this is the example of the multi-level feedback queue. Any question? So regarding to this one, this is part of your midterm exam also. Okay, so we talk about the scheduling algorithm for to speed up. I'm going to use the slide. So anyway, I'd like to finish the chapter 6 today. So far we talked about the scheduling algorithm for the processes. What about the thread? What is a thread, by the way? It's kind of a small process, lightweight process. It's like the process, which means it's a process, the sequence of the instruction. Okay? But to save the time of creation or management, instead of managing all the process structure, we are managing one. Only needed part. Okay? So which means even though the thread does not have all the process data structure, but we need to schedule the thread to process the instruction of the thread. So to do that, as we discussed before, the computer operating system is the dual mode. What is the dual mode? User mode and kernel mode. So which means, so if you remember the chapter 4, so we have the kernel thread and also user thread. So user thread, usually who create the user thread? Your application, your program. So using the system library, like the P thread. What about the kernel thread? Kernel, so if you remember the process list of the Unix system, for example, K thread, you have it. When we start up the operating system, so it creates a number of the thread. That works for the kernel thread. So which means so for the thread scheduling, we need the schedule for the user thread. That is called the process contention, that's called the PCS. Another one is the system thread, the kernel thread, that is a system contention. It's called SCS. So there are two types of the thread schedule. One is for the user thread, another one is for the kernel thread. So in case of the P thread, POSIX system library, POSIX Unix, they provide such the library for the thread scheduling. Okay. So for example here, so if you are programming using the POSIX thread, the P thread, you can set what is the scope of this is the user thread, this is for the kernel thread, and so on. So you can specify the scheduling algorithm in the program using the thread library. Okay, then that is for thread. Nowadays, most of the laptop is the dual core, or some of them are the dual processes. So it's a multiple processor. So in case of a multiple processor, how many scheduler do we need? It depends on the computing architecture. So, for example, when you are using the dual core, for example, dual core, so have you ever considered you have the multi-core or two-core or the full-core in your programming? Have you ever considered? No, you can just consider no matter how many core, how many processors you have, you just code, make a program. Or you can just use any application. Then, that doesn't mean that we ignore the number of processes, number of core. Instead, your operating system automatically considers multi-core and multi-processes. So that is called SMP, symmetric multiple processor. So symmetric multiple process means logically you consider number of process as one. Okay? Then your operating system will take care, which means in your scheduling algorithm, it doesn't matter how many how many processor or how many thread you have. It's automatically balanced, and so that will be considered in the multiprocessor scheduling. Okay, so anyway, to utilize the multiple processor, we have one processor, CPU, another process. So if you assign the old processor over here, the processor will be very busy. This processor is not. So first thing you need to consider is the balance. Okay, so when you think about the multiprocessor, the scheduling algorithm, how to balance. If this one is not used, you can assign select the processor for the unused process. At that time, we can think about the two affinity of the CPU scheduling. So one is a soft affinity and another one is hard affinity. What is the affinity? Affinity means so I have one process, then I select the CPU 1 to run this. Then running, then it will go back to the ready queue. Okay? Because it's the preemptive, the scheduling algorithm, it can go back to the CPU. Then next time when we select this processor again, which processor CPU will be selected? This one, which was used for the previous step, and or another CPU process. So if you stick on the one processor for the specific process, that is called the hard affinity. Otherwise, if you don't care, if you do not care which CPU will be used for the process, it's a soft affinity. At that time, which one will be better performance? Overall, it's a soft affinity, which means we don't care which one will be selected. So overall, it can be either depending on the situation, we can use this one, right? We can use this one. However, if we consider specific process, hard affinity may be better. For example, the cache information. Do you remember we discussed about the storage, the hierarchy from the hard disk drive, memory, and the register is the top. Fastest one, but smallest. Just beyond the register, what is the storage structure? It's a cache, which specifically is called the L2 cache. So each CPU processor has the cache area, which is called the L2 cache. For example, when you purchase a new laptop, you need to check your CPU, the capacity, like the clock speed, like the 3.6 gigahertz. What does it mean, 3.6 gigahertz? It's a wave. Okay. Anyway, our CPU is an electronic device. Electronic device actually is based on the electronic signal. It's a wave. Then one electronic signal, we can do something. For example, between the CPU and the memory, we transfer data through using what? Bus. Depending on how many lanes you have, it can be 16-bit computing and 32-bit computing or 64-bit computing. 64-bit computing means at one cycle, how many bits you can send? 64-bit, which means fast. Okay? So 8-bit computer, 8-bit processor. So at one cycle, you can send only 8 bits. So that's the cycle. So CPU cycle is also useful to process what? Instruction. So some of the instruction, simple instruction, you need only one cycle. But most of them need the multiple, the cycle, because it's a little bit complicated. When you design hardware, CPU, the processor hardware, so you need the 2 or 3. So roughly, we are saying per the instruction, we need the 2 cycle. Or you can check the specification. What is the average cycle per instruction, per the processor, the CPU. Then, roughly we are saying the cycle per instruction. How many instructions can you process in the 3.8 gigahertz? 1.9 gigatimes of the CPU. At the instruction you can process. That is the specification. Another one you need to take the C is what is the cache size. So 4 megabyte, 8 megabyte. The bigger is the better. Not always, okay? Because you have for example, the 128 megabyte L2 cache size. It takes a time. It's overhead to manage the cache area. So cache is not always good when you have the bigger size, okay? So it can be overhead. So that is the cache. So if you use the hard affinity, you may get the benefit of such a cache information. You don't have to recycle such a cache. So you need to consider depending on the situation, your operating system will take care of the soft affinity or the hard affinity. One of the examples of the multi-core, the multiprocessor, the architecture is the Newman, non-uniform memory architecture. Means that when we have the multiple, the CPU, the main problem is the cache area. Here the cache is the cache, the memory area. So CPU has a very limited storage, so definitely rely on the memory. Okay, but when we have such a multiple CPU, so if each CPU manages their own memory, the problem is that the global variable I is updated here, but how to access this one? So that is the problem. To not address, if you do not care the sharing the memory, it's called the parallel, the cluster system, parallel system. It's called the MPP architecture.